Okay, moving on, we are on question number 8. We are on question number 8. In question number 8, you are asked to show that the two lines intersect. Okay, what are the two lines? You have a line that is 5, 2, 4 plus lambda of 1, 3, 1. Right? This is the first line. You want to equate to the second line to find the intersecting point. Plus mu of 4, 7, 5. Okay, so to find the point of intersection between two lines, you simply equate them. So you equate the first component with the first component. So then you will have lambda minus 4 mu is equals to minus 2. This is equation 1. Right, I simply equated the first component with the first component. Right. What I've simply done is I've taken 5 plus lambda equals 3 plus 4 mu. So I do some tidying up. I get this. Let me measure it. Lambda minus 4 mu, 3 minus. Okay. Then the second equation will be 3 lambda minus 7 mu is equals to minus 1. Right. Then there's a third equation, which is lambda minus 5 mu. Lambda minus 5 mu is equals to minus 3. Okay. So in this kind of equation, in this kind of intersecting point between two lines, we always use two equations. In this case, I intend to solve 1 and 3. I use equation 1 and 3. If you solve 1 and 3, it's actually easier. If you solve 1 and 3, your mu will be equals to 1. And then so your lambda is equals to 2. And then since you have used equation 1 and 3, you check with equation 2. To check equation 2, does it satisfy? You put in the left hand side. You got 3, lambda is 2, right? Minus 7, 1. Get 6 minus 7 equals to minus 1. So it's consistent. Right? The solution for lambda and mu is consistent for all the three equations. That implies therefore the lines meet. Now that you know the two lines meet, how do you find the point of intersection? You have two choices. Either you put lambda as 2 into here. You put lambda as 2 into here, right? You get 7. You put lambda as 2 inside here, 8, 6. You will get the same thing if you put mu as 1 to here, no? 7, 8, 6. It's not surprising, right? Yeah, it must tally. So that's why they do meet, is it? Otherwise they don't meet. And now in number 8, the same question of 8, you're asked to find the cosine of the angle between the two lines. How do you find the cosine of the angle between two lines? To find the cosine of the angle between two lines, it goes like this now. Okay, for number 8, 8, continue. Cos theta. To find the cosine of the angle between two lines, you just take the two directional vector 1, 3, 1 dot with 4, 7, 5. Then divide by its modulus. This is root 11, and this is root. How to find the modulus? You square, 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 right? Square 90. I want to caution you, although it's not needed, to find the cosine of the angle between two lines, you actually need this modulus, because you want to make sure that you truly get a acute angle, right? When you talk about angle between two lines, it must be the acute angle between them. So this give me 30, I believe 30, right? 21, 25 plus is 30. 30 divided by square root of 11, square root of 90. Cancel by 10 is 3. Sorry, I think I don't then cancel by 3. I get 10. Then this gives you cancel by 9. This 110. Right. Right. And this is the same if you do your rationalization, the same as 110 divided by 11. It's the same. Alright, it's the same. That's how you find the cosine of the angle between two lines. And then let's do question number 9. P and Q. Show that PQ has a length of 9. Question number 9. Let me do question number 9 here. Question number 9. Okay, so you have OP and OQ. So PQ, if you look at the given vectors, right? PQ is obviously OQ minus OP. And this gives me, if I take OQ minus OP, it gives me 6 minus 6 minus 3. Okay, the vector will be, is actually 6 minus 6 and minus 3. So now to find PQ, right? When you say PQ, like just like that, right? They actually meant the magnitude of PQ. How to find magnitude of PQ? You just square it 36 plus 36 plus 9, and this gives you 9, right? Because it's square 81, easy. So I've proven that PQ is exactly 9. Then you're asked to find the unit vector in the direction of PQ. Okay, so they're asking for this unit vector in the direction of PQ means PQ divided by its magnitude. Right, to find unit vector in the direction of vector, it's always like this. So this gives me 1 over 9 of the vector PQ. And this gives me 1/3 3 minus 2. This gives me 2 minus 2 minus 1. So this is the vector that is so-called a unit vector in direction of PQ. And then you want to find the Cartesian equation of the line PQ. Okay, line PQ, right? Line PQ is R equals to a first vector. Conveniently, I'm going to use P, which is 3 minus 1, 1 plus lambda, the vector PQ. I could use a smaller version of this. I could have chosen 2 minus 2 minus 1. So if you have an equation of a line like this, bear in mind this vector, right? I've actually used a smaller version of this. I could use PQ, no? I could use 6. I could have used this vector, right? I could have used this vector, but I have chosen to use a smaller version of it, right? Okay, so if I ask to write down the so-called Cartesian equation, it goes like this now. To find the Cartesian equation, right? Cartesian equation goes like this. It'll be x minus 3 over this number 2 equals to y minus minus, y minus minus is a plus 1 over minus 2, and z minus 1 over this minus 1. So this is actually the Cartesian equation of the line PQ. And then the next two part, the line which passes through point P has this equation. So now is another part of it. Okay, maybe I should just another part of it. No, the diagram for this part is like that. This is the line. It passes through P, and then Q look like this. Right, Q look like this, and then this line has this equation. This line is called L. Okay, let me write down L. L. Okay, L will be like this. It's given to you to be this one. 3 minus 1, 1 plus, say, let me use a different, use mu of minus 2, 1, 2. Okay, this is another line L, and this line L contains the point P, or rather P is on the line L according to the question, right? So in this case, they want you to find the length of projection of PQ on the line L, and they also want to find the distance from Q to the line L. So this question actually asks you for two lengths. It asks you for this two lengths. Okay, this question asks you for two lengths. This is your so-called part 1, and this is your part 2. Now, to do this question, one way to go about it is to first and foremost find out this angle first. Find out something about this angle first. Let's call this angle theta. Right? Bear in mind that you actually know that this length is actually 9. Right? This length is actually 9. Right? So I intend to actually find so-called the angle between this vector PQ and the line. How do you think that you can find the angle between PQ and the line? The method is quite similar to what you have in number 8. You know, I'm going to borrow the same approach that I've done in number 8. I'm going to erase off this. This is not number 8 anymore. This is number 9. Continue. I'm going to erase off this portion. This portion again. This portion. Here's this portion. Alright, so I'm going to do a similar step like what I did earlier on. I intend to find this angle theta first. How do you find the angle theta? Earlier on, we had the case of angle between two lines in number 8. Now it's angle between a line and a vector PQ. The same steps is to be used. How do you do it? I'm going to write number 9. Continue. Okay, you can write as cos theta. Cos theta is equals to, take the vector PQ, which is this. The vector PQ is 6 minus 3, dot with the direction vector of the line, which is minus 2, 1, 2. Then divide by the magnitude of this, which is 9, and then the magnitude of this, which is 3. Now, I told you before, to find angle between two lines, it must be the acute angle. And I want you to know that between a line and a vector, it also must be an acute angle. So if you perform your dot product, the numerator will result in minus 12, minus 6, minus 18, minus 24, minus 24. Right, you have minus 24 on the numerator, cancel 3, cancel. Minus 24, cancel 3, you get 8 over 9. You get a value of 8 over 9. Right. So now if you now know that the cos of the angle between the vector PQ and the line is 819. Now we are ready to find this number, the length of projection of PQ onto this line. How do you do it? Based on this diagram, right? Adjacent over hypotenuse is cosine, right? Adjacent over hypotenuse is cosine. So this adjacent therefore is 9 times the cosine. 9 times the cosine in this case, right? So this goes to 9 cos theta, and this gives you a value of 8. Alright. So now that you know this length is 8, you can then use the Pythagoras theorem to find this other side. Right? So this is how you can actually find the length of projection of the vector onto the line PQ. And that completes question number 9.